Hey everyone, Laz here from Adatis, and today we'll be continuing with part 2 of a 3-part video series, all on Power BI performance tips. So if you haven't seen part 1, which contains the first 3 tips, be sure to go ahead and check this out and then jump back to this video afterwards. Otherwise, let's go ahead and look at the second set of 3 tips that should help you see better overall performance. So, continuing with tip 4, which is we should try and push our transformations back to the source, as this can reduce the resources required to process an import and increase query performance. Now, Power BI stores data in memory, which of course offers many benefits, but it will be less efficient for us to go and load all data into memory first and then apply transformations to this data. Instead, we should apply our transformations directly in the source and simply load the result into Power BI. Now, you're probably thinking, well, this needs some work directly on the underlying source. I don't have permissions, or I don't want to go ahead and change any SQL tables or views. But there is no need for that. This can all be done directly in Power BI Desktop using something called query folding. So let's go ahead and check this out.
So we are back in Power BI Desktop and we are connecting to an AdventureWorks database again to showcase these performance tips. From here, we're going to go to Power Query, which of course is a data transformation component of Power BI. So we're going to click Transform Data. And once we're in Power Query, we are going to go and select our DIM product. And we can see that we already have some transformations in here by looking underneath the applied steps on the right-hand panel here. Now the question is the data for DIM product being loaded first from our SQL database and then this transformation here is applied? Or is this transformation happening on source side and the result is simply loaded here? Well, to check this out, we can simply go ahead and right-click on the last transformation in the list, which as we can see is removed other columns. And if the View Native Query option is enabled or clickable, as we can see here, so it's not grayed out, this means that this transformation and everything above is happening on the source side. So I can go ahead and select that, and there you go. You can see the SQL query.
So this is query folding, and we can see it's enabled directly here in Power BI Desktop. So we should go ahead and promote this whenever possible.
So query folding is the process of converting all the transformations applied in Power Query, which are written in M, as we can see by selecting the advanced editor up here, to the native language of the source, which is SQL in this case. Therefore, all transformations are not completed on our machine, but instead on source side. Now, I can add another transformation, such as I want to rename, let's say, English product name to just product name. And we can see that if we right-click on the new transformation step, that View Native Query is still or available to be clicked. Therefore, this is being folded back to the underlying data source. However, if we now go ahead and add another transformation, such as index column, so go to add column, and then we can select index column from here. Notice that if I go ahead now and right click on added index, View Native Query is no longer clickable. And it's important to know that not all transformations are supported for query folding, and they simply won't fold back. So everything above this transformation here is being folded back to the source, but all transformations from the index column and downwards will be done directly in Power BI. So to show this, if I go ahead and add another transformation, such as, let's just go ahead and filter product name for now. And let's say, well, we just want to remove BB ball bearing. So I'm going to click OK there. There we go. So we can see that we have a filter transformation, and we know that this does support query folding. However, if I go ahead and right click that, notice that view native query is not clickable, meaning that this is not being folded back. So let's go ahead and reorder this by adding it on top of added index in the transformation lists. And now if I right click it, the exact same transformation, notice that view native query is clickable, right? And this is something that we should be doing. So let's go ahead and group all our transformations that do support query folding together wherever it makes sense. And then those that don't support query folding can be added afterwards or closer to the end of applied steps as well. So that is essentially query folding. One last thing just to mention, the underlying data source must accept query folding requests, and if it does not, you simply cannot use this. But let's make sure we are using query folding as much as we can to push transformations back to the source.
The fifth tip is to remove any tables that are not needed in the data model by disabling queries from loading. I find it's a very common thing to have tables loaded into the data model when they are only needed as transformation tables in Power Query. So they are using up precious memory unnecessarily. So let's go ahead and check this out.
Here we are back in Power Query. Now, to showcase disabling load to queries, let's say we don't want to have two tables for dim product category and also dim product subcategory, right? We simply want to combine these two tables into a single table, so it just makes it easier for the user to find the columns they need, and also it aligns more to a star schema, which we will be talking about in the next video as well. So for that reason, I can go ahead and merge them together by selecting on dim product subcategory. And then from there, I am going to go ahead and go to transform, or no, I'm going to go to home, and I'm going to select merge in the top right here. Now, once I have done that, I'm going to say, well, I want to merge dim product subcategory with dim product category, and I'm going to join these on product category key. So I got my product category key here and my product category key in this table. I'm going to leave it as is, and I'm going to go ahead and click OK. And then I will go ahead and expand to return back English product category name. I don't want anything else, and I don't want the prefix. I'm going to click OK on that. Oh, there we go. Click OK on that. And there we have it. We have a single table now rather than two, because everything that we need from dim product category is now available in dim product subcategory. So I can go ahead and click close and apply. And by default, Power BI or Power Query essentially will go ahead and load all these queries here, which are tables, to the data model. And more importantly, all of these will be consuming memory. So what we should do here is we should go ahead and we should right click on dim product category, and you'll notice that something called enable load is already ticked. So let's go ahead and unselect this. And as soon as we do that, you'll see this message appear now, which can be worrying if it's the first time you're seeing it. Possible data loss warning.
All this is telling us is if we have any visuals using columns from here, or maybe any DAX measures referencing columns from this table, they will be broken.
But we don't care, as we have all the data we need in dim product subcategory. As we said, we use that merge, so the data that we needed from dim product category has been added to dim product subcategory. So I'm going to go ahead and click continue. And one thing worth pointing out, now that we select continue, notice that dim product category is being displayed by Power BI in an italic font. And that's just Power BI telling us to sort of take note that this query here has enable load unselected, therefore it will not be loaded into the data model. So with that said, I can now go ahead and click close and apply. But before I do that, I'm just going to jump back in here and notice that we have dim product category and dim product subcategory. And let's now go ahead and click close and apply. And once that has been loaded, so it'll just load the changes. So you can see that we just displayed dim product subcategory because we made changes there. And also dim product category is not being displayed back. Now the data has been loaded, you will notice on the right hand side under fields, we no longer have dim product category. And it just means that all transformations are still going to be working as expected in Power Query, but simply the data from dim product category will not be loaded back into the data model. So if we have any tables that are only needed in Power Query, as we saw now, or maybe as a staging table, but we do not need it in the model later on to be used for reporting, let's go ahead and disable enable load.
Finally, tip number 6. It may be a simple one, but we should definitely promote this. Let's use integers before strings. Now, as mentioned in part 1 of this video series, Power BI works through the VertiPack engine, which is a columnar storage engine, therefore compresses columns. And this engine is highly optimized for working with integers. So we aren't going to go into the details of the 3 types of compression that the VertiPack engine runs, but if you do want to learn more on this, feel free to reach out. And also, I'd highly recommend reading the book, The Definitive Guide to DAX. However, to explain why we should use integers, we should always try promote the first type of encoding, which is value encoding, rather than dictionary, also known as hash encoding too. Anyway, let's go ahead and check this out.
So we're back in Power Query and we are on fact internet sales. And one of the columns that we have in here is the customer key. And this is a foreign key, which has a relationship to the primary key in the customer table or dim customer right here. Okay. And as you can see, customer key is an integer as we have 1, 2, 3, which is a whole number. And this is a good thing. That's what we want, as many of our columns as possible to be integers. And this is especially true in our fact tables, as the only thing that we want to have in here are numerical columns for deriving measures, and foreign keys are integers for establishing relationships back to other tables, which are our dimensions. Now, as mentioned, we have 2 types of encoding: value encoding, dictionary encoding. So this column here, customer key, is using value encoding. So to showcase this, I'm just going to take a copy of this column and paste it into Excel. And this is just to give a bit of an example of how the VertiPack engine applies value encoding to an integer column. Okay, so the first thing I'm going to do, I'm going to order the customer key, so smallest to largest. And the reason I've done that is to find the minimum value, and this is the minimum value over here, right? Minimum value. So when the VertiPack engine applies value encoding to customer key, it takes the minimum value from customer key, which is 11003. So I'm just going to, for example, I'm just going to put it all the way down so we can see how it works. And then the VertiPack engine derives a new column with value encoding. And the way it does that is by taking the minimum value and subtracting it by all the other values. So it goes to the original value, customer key, and subtracts it with the minimum. And this is repeated across every value, right? So like we can see on screen. And what does it do? It essentially reduces the number of digits, as we can see. And by reducing the number of digits, this means the number of bits consumed. And if we have millions or billions of rows, this really does help. Now, at query time, in order to retrieve the correct customer key back, the Vertipack engine will just simply add the minimum back to the number originally subtracted. Okay, so all it will do, it will essentially take the minimum and the value subtracted essentially. So you can see these two values, or let's take another example, 11003 plus 5 gives us 11008, which is of course the original customer key. So without going any more in detail, this is value encoding and something we should always promote. Now, to make more sense why we should use integers, let's have a look at dictionary encoding. So I'm just going to create a new sheet here. So let's say that customer key is not an integer. Instead, it's a text column. So if I go into Power BI, just to make that clear, to showcase dictionary encoding, let's say that customer key is not an integer. Instead, it's a text column. So I'm going to replace that. And if I went ahead and copied that out, which is essentially the same thing as customer key here, and let's add it in here for now to showcase this, right? Now, value encoding simply will not work on customer key, as customer key is a text column. Quite simply, it needs an integer, right? It cannot subtract text from text. That just doesn't make sense. But that's not to say Power BI won't still compress this column or any other text column, and this is when it uses dictionary encoding. Now, the way this works, it creates a dictionary table, and this dictionary table consists of two columns. So let's showcase how this dictionary table will look for customer key. So I'm going to take the customer key as it is, and I'm going to go ahead and remove duplicates from there. So the first column a dictionary table will have is a column containing the string value, which is essentially the same as we have here, but of course it removed all the duplicates, okay? And the second column is a ID column that uniquely identifies each of the string values as well. So in other words, it would be essentially 1, 2, 3, 4, all the way down, so you get the idea. Now, once this date dictionary table is created, which by the way does consume space and does consume memory, so already you should start to get a bit of feel and understanding why we should promote to have integers over strings as well. We don't want data dictionary tables to be created when they can be avoided. But anyway, once this data dictionary table is created, the IDs from the data dictionary are referenced to the values in the original column. And the logic here is that integer values require less space than text values. Now, just an important note on this as well. Higher cardinality in columns results to larger volumes of memory consumption from the data dictionary. And this is why in the previous video in part 1 we said let's try reduce or even remove high cardinality columns as much as possible. But anyway, after highlighting dictionary encoding, we should aim to use integers over string values, as we would be promoting value encoding, which we saw here, which does not create a data dictionary table, which again, this does consume space or memory, right? So in Power Query, let's make sure as many or all the columns that it makes sense for, these should be integers. So I'm going to go ahead and turn that back from ABC, which is text, to an integer as well.
So those were the second set of Power BI performance tips. I hope you found these tips useful and help you with optimizing your Power BI solutions, and look forward to seeing you in the final part of this video series, where we will be exploring 3 additional performance tips. Take care for now. You in the final part of this video series where we will be exploring 3 additional performance tips. Take care for now.